Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question from one of the old C34 papers from before the new syllabus started. And this particular question relates to P3, trig identities and equations. And here we have a question number 13, part A, where we're told to express this expression 10 cosine theta minus 3 sine theta in this particular form, where you express it as two separate ratios into one ratio, but now with a compounded angle. So the angle theta now becomes theta plus alpha, where alpha has to be found, and it's an acute angle, and it's some multiple times that. Now this is a useful form for us to rewrite something like this for many reasons, one of them being solving trig equations, one of them being drawing the graph of such functions, and so that's something that we should know how to do. And to rewrite this in the form required, so we've got to take 10 cosine theta minus 3 times sine of theta, and we have to rewrite it in the form where you have a constant r, which we have to find, times cosine of theta plus alpha. Now, to do that, we should know what are called the addition formulae. And these are found in the formula book. And if you look in the formula book, you'd find some formula that look like this. You'll see this in your formula book. That's what you'd see. And we can use this to help us to expand this cosine theta plus alpha. Many people, in the beginning especially, they think that this is cosine theta plus alpha will become cosine theta plus cosine alpha, completely misunderstanding what the whole of a trig function actually is. Because by itself, this means absolutely nothing, right? It has to have an angle associated with it. And the angle is the whole of this theta plus alpha. They're together. The integral part of this is, the cosine is the angle that it's the cosine of that angle, right? So you can't take it like as if it was, for example, x times theta plus alpha. Now that would give you x theta plus x alpha. That's fine, but this is completely wrong. So to expand something like this, we have to use what I call the addition formulae, which are given here in the formula book. We don't really need to know how to derive them. They can be derived, but it's not the place right now to do it. We just need to know how to use this, expansion. And once you've done it a few times, you find how easy it is. So we got here cosine theta plus alpha. So cosine A plus B. So it's like our theta is A and our alpha is B. And we got the one with a plus between them, which becomes a minus when you have the expanded form. So we're going to have, this is going to become r times, because it's all multiplied by r, cosine of what comes first. So it's cosine of theta. And then you'll have, so this is theta and this is alpha, this is theta and this is alpha. So cosine theta, cosine alpha. Okay, and then you're going to have minus, that's a plus, that's a minus. That's a plus, that's a minus. And then you still have your r, because your r is multiplying the whole thing, so it's going to multiply both these terms. And then you're going to have sine theta, sine alpha. Sine theta, sine alpha. So for cosine, it's always going to be cosine of the angle times cosine of the other angle, and the opposite sign. If it's plus, it's a minus. As you can see, the opposite signs. And then r times sine of the angle times sine of the angle. Okay, sine theta, sine alpha. And that's what this 10 cosine theta minus 3 sine theta has to be rewritten like. So this is like an identity. They're exactly equal to each other, exactly the same, identical. All right, so we can use the fact that these are identical in order for us to find the value of r and find the value of alpha, which is what we need to do to write it in this form. And what we can do, in order to do that, what we need to do is we need to what's called compare the coefficients. Okay, so I'm going to compare the coefficients of the cosine theta on this side. And you can see there's a cosine theta on that side. So I'm going to highlight those. And I can see here that on this side, the coefficient of cosine theta is 10. Oops, my pen's got messed up. Okay, on this side, cosine theta has a coefficient of 10. On this side, the cosine theta has a coefficient of r and cosine alpha. So 10 equals r times cosine alpha. That's comparing the cosine thetas. And we can also compare the sine thetas. Okay, the sine thetas. You have sine theta here and you have sine theta there. So we can see on the left-hand side, the coefficient of sine theta is minus 3, but because there's a minus here and a minus here, I'll just put 3. Okay, and here, if you look at the sine theta here, you got r sine alpha. You can say minus r sine alpha, but that's going to cancel out because there's a minus on both of them. That's r sine alpha. So r times sine alpha. So what we can do from this is we can work out the value of r and theta alpha, and there's different ways to do it. I personally like to do it in this way. I like to rewrite this as cosine alpha equals, if you divide both sides by r, 10 over r, and here I have the sine of alpha equals 3 over r, and then I can draw a right angle triangle. So I can draw a little right angle triangle. Okay, and I can say if this angle here is alpha, so if this angle here is alpha, and this is a right angle triangle, then the cosine of alpha is adjacent, which would be here, 10 over r, and the sine of alpha would be opposite, which is 3 over r. Okay, so we can see from here that r can be found by using Pythagoras' theorem. It's going to be the square root of 3 squared plus 10 squared, which r is going to be the square root of 109. Okay, so it gives the exact value of r, so we leave it like this. We'll just check to see in case. I don't think this has a perfect square factor, but if we put the square root of 109, we can make sure that we can't simplify it. No, that doesn't simplify. So there's r, so we found what r is. And then we're going to find alpha. Now that's pretty simple. We can use tangent. We can say the tangent of alpha is equal to 3 over 10, opposite over adjacent. So alpha is equal to the inverse tan of 3/10. So we have to make sure that we are in degree mode, because we're dealing with degrees here. Okay, and so we say, are we in degree mode? Yes, we are. So inverse tan of 3 over 10. And that gives us the angle, which is 16.6992. So that's 16.6992. And we have to write the answer to 2 decimal places. So we can say alpha is therefore equal to 16.699. So that's going to become 70. So you should write it to 2 decimal places. That has to become 70. And we have to write the 0 there. If we stop here, okay, we have to write the second decimal place. This 9 makes it become 10, which makes this become 7. So you have 70. We don't say, oh, the 0 doesn't make a difference. No, they've told us to round it to 2 decimal places. So you have to put the 0 there. Very, very important. So the question told us to find the value of alpha to 2 decimal places, which we've done, and find the value of r in the exact form, which we've done. And there's the answer. But what I'm going to do, just to make it look complete and maybe help us for other parts of the question, is just write down over here what we found. We found that 10 cosine theta minus 3 times sine theta is equal to r, which is root 109, times the cosine of theta plus 16.70 degrees. Okay, so that's what we've just basically proved. We've just shown that by using this method here. There are other methods of from this. Once you got to this stage, some people, for example, they would take this equation and they would square it. Take this equation and they would square it, and they would add the 2 equations together. Okay, so for example, if they square this, they're going to get 100, and square this, going to get 9, so, and you add them to get you 109. If you square this, you get r squared cosine squared theta, alpha, plus r squared sine squared alpha. So when you take out r squared as a common factor, you have cosine squared alpha plus sine squared alpha. Now we know that equals 1, so you'll end up with r squared equals 109. So r is equal to the square root of 109, which we found. And to find tan theta, they would divide this way. They would say, if you divide these 2 equations, you put r sine theta over r cosine theta, which is tan theta, equals 3 over 10. and you will end up with the same answer. So there's alternative ways of doing this. I personally just like to draw the triangle, but you can do it in this kind of more algebraic method. If you wish, that's perfectly fine. Okay, so there's no problem with whichever way you do it. You can get this answer as long as it's correct. So there we have 13a, and we have rewritten this in this form, which we'll see now the benefit of doing so in answering some of these questions. So it says Alana models the height above the ground of a passenger on a Ferris wheel by the equation h equals 12 minus 10 cosine 30t degrees plus 3 sine 30t degrees, where the height of the passenger above the ground is h meters at time t minutes after the wheel starts turning. It says calculate the maximum value of h predicted by this model and the value of t when this maximum first occurs. Give each answer to 2 decimal places. So here, there's no mention of any connection between part A and part B. But in these type of questions, there always is a connection. So if we look at what they've given us and what we found, you can see here that there's a very great similarity between these things. This is 10 cosine theta minus 3 sine theta. So if you notice just this part of this, you have, we just do that in a clearer color, 10 cosine 30t degrees minus plus 3 sine 30t degrees. So it's almost the same, but the difference is the minus and the plus sign. Okay, the minus and the plus sign. However, if you think about it in this way, if you think about it as h equals 12 minus, and you put in brackets, if you put a bracket here, you'll have 10 cosine of 30t degrees, and then you'll have to put a minus here for this to become a plus, 3 sine 30t degrees. Now what's here in this bracket is exactly the same as that. These two are the same. We have 12. So I'm going to write this out over here to make it clearer. So we start off with h equals 12 minus 10 cosine 30t degrees plus 3 sine 30t degrees. And we can see that if I rewrite this slightly so that I want to make this look like what we found, I have 12 minus, I can put a bracket here. This becomes 10 cosine of 30t degrees. Then this has to become a minus, because when I expand that, that's going to become a plus now. So that has to be a minus here, 3 sine of 30t degrees. Now what I have in here is exactly the same as what we had over here, except the difference is the theta has now become 30t. So here it's like the theta became 30t degrees, right? So it's like 10 cosine theta minus 3 sine theta, and we know that that can be rewritten in this form. So instead of writing 10 cosine theta minus 3 sine theta, I can write the square root of cosine of the angle theta, or in this case 30t, plus 16.70. So I can rewrite this now as h equals 12 minus the square root of 109 times the cosine. Instead of putting theta, I can put 30t, and I'm going to put plus, and I have our angle, which is 16.7 degrees. 16.70 degrees. So there we have rewritten this expression using part A, even though they didn't tell us to use part A. In this type of question, it's almost, kind of like, certain that you have to use part A. Whenever they've told you to do this, it's for a reason. Okay, when they've asked you to express in this form, it's either to solve an equation or to draw a graph, something which writing in this form, it makes it much easier than keeping in that form. So now it's asking us to find, so this is getting ready for part 1. Part 1 says calculate the maximum value of h predicted by this model. So we've got to find the maximum value of h. Now that's pretty easy now. Okay, because if I think about the expression that we have, 12 minus the square root of 109 times the cosine of 30t t plus 16.70. Now the cosine of any angle, can never exceed 1. This is the cosine of an angle, okay? This plus 16.7 just is a horizontal shift, okay? But this itself, this from here to there, the maximum value of this is always 1. The maximum value of this is equal to 1. And the minimum value of this is equal to minus 1. Okay, but we've got to find what the maximum value of h is. So if we think about h equals 12 minus, supposing I call this 1, this would be minus the square root of 109 times 1, which is 12 minus the square root of 109. Now, is that the biggest it can ever reach? Well, let's see. If you have 12 minus the square root of 109 times, now the smallest this can ever be is minus 1. Now, because this is being subtracted from 12, that will make it become 12 minus, which is plus the square root of 109. And that is bigger than that. That's the biggest it can ever become. Because you've got 12 minus root 109. So when this becomes minus 1, this becomes plus root 109, and you end up with 12 plus root 109. So this is like you could say the smallest value it can become, and this is the biggest value it can become. So you can say the maximum value is the square root of 109. And when does it first? Now it says give each answer to 2 decimal places. So I have to round this to 2 decimal places. So I have the square root of 109 is equal to. Let's just work that out first before we continue. You could read the question very carefully. So the square root of 109, okay, the square root of 109, that gives us 10.4403, so 10.44. So we got here 10.4403, so that's going to be 10.44. That's the maximum value rounded to 2 decimal places. Now, when does the maximum occur? Now, I don't really have space here. I'm going to continue the next page. But the maximum occurs when this is equal to minus 1. Okay? So the maximum occurs when the cosine of 30t plus 16.7 is equal to minus 1. I'm just going to put this on the next page. So the maximum occurs when this is equal to negative 1. All right, that's when the maximum occurs. So when the cosine of 30t plus 16.70 is equal to negative 1. So if we find the inverse cosine of negative 1, that's going to give us 180 degrees. As we know, that's the first time it occurs. That's 90, that's 180, 270, 360. So that's when you get negative 1. So we can say that's when 30t, when the angle 30t plus 16.7 is equal to 180 degrees. And it's asking us for the value of t when the maximum first occurs. So first occur, okay, at this point here, okay, it's gonna occur again down here later on, but we're not concerned about that. We're concerned about when it first occurs. That's when the angle here is 180. So that's why that's equal to 180. So we can say 30t is equal to 180 minus 16.70. So t is equal to 180 minus 16.70 divided by 30. So that should give us an answer, which again we round to 2 decimal places. So we have 180, take away 16.7, divided by 16.7 divided by 30. I mean, when we write this out, it doesn't make any difference, but when we have to show it, it does. Okay, so that gives us 5.44333. So 5.4433 continues. So we want that to be to 2 decimal places, so 5.44. So t equals 5.44. That is the solution, okay, for B part 2. Now for question C, it says calculate the value of t when a passenger is 18 meters above the ground for the first time. So I'm going to take this again. I hope it was all there. Yeah. So we want to know when this expression here, okay, is above 18. So we'll find out when it becomes 18. Okay, so for the first, so let's find out when t becomes 18 meters first. When h becomes 18 meters, not t. So we got to find when let's find when h is equal to 18 meters first. Let's do that. All right, so we can just basically equate this to 18. So we have 12 minus the square root of 109 times the cosine of 30t plus 16.70 is equal to 18. Okay, so now we got to solve this equation. So what I'm going to do is I'm going to subtract 18 from both sides. So I have 12 minus 18, which is negative 6, equals, I add this to both sides. So I'll have the square root of 109 times the cosine of 30t plus 16.70. Then I can divide both sides by root 109. So I'll end up with cosine of 30t plus 16.70 is equal to negative 6 over the square root of 109. So this will give me that 30t plus 16.70 is equal to, so we can work out the angle by using this ratio. So we say inverse cosine of, we have negative 6 over the square root of 109, and we can work out what the angle is. That's going to be 125.0783, 125.0783. So we want to find the smallest value of t. So that's the first solution, and that's what we need. It's a positive value, it's fine. All right, so that's the first time. Okay, the first, that will give us the first solution, but we had to solve for t. So we don't want this, we want t. So we're going to subtract. So we say t equals 125.0783, okay, minus 16.70 divided by 3, and that will give us what we're looking for, the value of t when it's 18 meters above the ground for the first time. So we take this angle and we say the angle, the answer, minus 16.7 divided by 30, divided by 30. What am I doing? Okay, be careful about silly mistakes like that. And that gives us 3.61261, 3.61261. So we can therefore say it's t equals 3.61. That's the value of t, okay, to 2 decimal places again. All right, so there's part C. Now for part D. Okay, it says, determine the time taken for the Ferris wheel to complete 2 whole revolutions. All right, so we got to find the time it takes to complete 2 whole revolutions. All right, now, there's a number of ways of doing this. Now, the most obvious way to me, okay, is to do the following. Let me just take this. I think there's a way of doing it by looking at this equation, okay, but to me the most obvious way of doing this, if I was doing this in an exam, is as I would use my answer that I got here. So I would say, okay, this is the first time it reaches 18 meters. Let's find how long it takes to reach 18 meters the second time, okay, the next time it reaches 18 meters, and then we can double that time. Okay, because you find out how long it takes between getting to 18 meters the first time and the second time. So you find the second time it reaches it, subtract it the first time, and then double it. Or you can find how long it takes to get to 18 meters, not the first time. Well, the first time, the second time, and the third time. So when we find the time between the first and the third time, subtract them. That will be the time it takes for it to go through 2 revolutions. Okay. So we could use that. So that's what I would probably do in the exam. All right. But I think there's an easier way that the mark scheme shows, but that's not so obvious. So what I'm going to do is I'll show you what I would have done if I sat this exam. I would have said, okay, we know that 30t plus 16.70 equals 125.0783. We want to find the next time where it is in that same position as this. Okay, where it's 18 meters, it completes 2 revolutions. So I don't want to know, for example, supposing it reaches 18 meters, supposing this is 18 meters over here. Okay, I don't want to know the next time it reaches 18 meters, which is over here. Okay, I want to know when it's gone through a whole revolution. So I'm not looking at I'm only looking at this and the next whole time it comes back to this position, which will be this plus 360. Okay, 125.783 plus 360. But in fact, I don't even want that. I want the one after that. So I'm going to add plus 720. This will be the first time it reaches 18 meters, say on the way up. And then the next time it reaches that same place, after having done 2 revolutions, would be 720 more. Okay, so if I now find, I know this time already, this time is 3.61. I need to find what this time is. So I can say 30t plus 16.70 is equal to 125.7083 plus 720. Okay, so now I can say t is equal to 125.0783 plus 720 minus 16.70 over 30, and that will give me the time it's gone past here. Like after it's reached 18 meters, it's gone around once and then twice. Okay, so if I calculate this, so I end up with, let me go back to, okay, we got this answer, right? So I'm going to take this answer, I'm going to add 720, then take away 16.70, and then divide by 30. And that gives me 27.61261. 27.61261. Okay, so what we can say here is the time is going to be, the time for 2 revolutions is going to be this time here, which is 27.61261. So 27.61 minus 3.61, which is 24 seconds. Okay, so as I mentioned, this is the method that I would use to solve this equation, to answer part D. Okay, you could also, I'm guessing, use the fact that you have this cosine 30t plus 16.70. All right, so h equals 12 minus the square root of 109 times that. Now, if you think about it, we want to find how many times this thing repeats itself, goes back to the same value again. So it's basically asking us to find the period of this function. Okay, so we can see that if we think about this, that the period of this function is the cosine curve. In general, the cosine of an angle, its period is every 360 degrees, right? And the root 109 doesn't change that. It still has that same, it repeats every 360 degrees. Root 109 just makes it go taller, that's all. But it has the same, period. It still repeats in the same manner. Okay, every 360 degrees. So the cosine curve, like say, between 0 and 360 goes like this. Okay, the root 109 makes it just go higher. The minus makes it just become like upside down. The 12 just raises it up a bit. So like the minus will make it go like this. The multiplying by root 109 just makes it like stretch vertically. All right. And the 12 just raises it up 12 units. Okay. And the 16.7 will cause it to translate horizontally, but the period will still be the same. Okay, that won't change the period of the function. It will just change, the position of where it repeats. Okay, or where it touches the x-axis. But that what will change it is this. This is what changed the period. Okay, so the period, instead of being 360 degrees, it's going to be 360 divided by 30, which is going to be 12. 12, right? That's 12. Yes, that's right. So that's one period would be 12. That's how much time it would repeat every 12 seconds, we could say, right? You can say that 30t equals 360, so t equals 12. Therefore, 2 periods is going to be 24 seconds. Okay, so that's probably an easy way of thinking about it. If you think about the transformation of the function, okay, this is the way that I would have done it probably in the exam. But after having looked at the mark scheme, this is the way that they've mentioned, and it's to do with how often this curve repeats. That's what we're looking for. How often this thing repeats? It repeats the cosine curve repeats every 360 degrees. Something is, and so this transformation of the cosine curve will repeat every 12 in terms of t seconds here. Okay, so here the angle axis is now the time axis, so every 12 seconds. So 2 revolutions will be 24 seconds, as we found when we did the method that I used. So either of those 2 methods are perfectly fine. Okay, and you get the right answer. This is probably a quick one to get to if you think about it. All right, but that's I guess a special way of thinking about it. But that's fine, that's good. So that's answers this question. Other questions from this particular paper can be found in the playlist that will appear in the top over here. Other questions from the topic of trig identities and equations from P3 can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video here which will tell you how to use my channel in order to find what you need quickly. Thank you for watching, and see you soon.